Hi, grade girls. We're going on to the next section in science today, which is 4.3.3, and we are going to be talking about pulleys, which is another type of simple machine that is used in our everyday life, and there are different degrees of pulleys. And pulleys, again, are a machine that's created to help lift something of weight without needing to use all of the force from your own body to do so. So this is a machine that allows us to pick up heavier things with less force or less strength on our own part to be able to lift pretty heavy things. All right, so we are on page 255 in your science book, and we're going to read about some pulleys. Have you ever been to the top of a skyscraper? How do you get up there? You probably rode in an elevator. Without elevators, skyscrapers would be very impractical. Elevators depend on simple machine, the pulley, to lift a load of passengers. The pulley is a simple machine consisting of a rope or cable that turns around a wheel. Often, the wheel is grooved to keep the rope from slipping. There are two types of pulleys, fixed and movable. So if you think of an elevator, you have a box of steel that can hold a good amount of people, usually up to about 1,200 pounds worth of people, and it's being lifted and lowered by a steel cable. That's it. But because of pulleys, because of a system of pulleys, it's able to lift that weight without snapping the wire. And if you were to try and pull that up on your own, or if a machine was trying to just pull it straight up on its own, that would be really difficult. But with the pulley system, it actually puts less effort on the machine pulling the elevator up and down and allows it to do it with ease. A fixed pulley. A fixed pulley attaches to something that does not move, such as a door frame, a ceiling, or a tree branch. A fixed pulley changes the direction of the force that must be exerted, but it does not decrease the force. Because the distance through which the effort force and resistance force are exerted is the same, a single pulley has an ideal mechanical advantage of 1. By using a fixed pulley, you can pull down on a rope in order to pull up an object, which is often easier than lifting an object straight up. So if you have a fixed pulley, you have it attached to, let's say, the ceiling or a tree, like it said, a door frame. And so what you have is you have your load or your object that weighs something, and the rope goes up and through the pulley, and then you're pulling down with your force in order to lift that load. Okay, and this is a fixed pulley, which has a mechanical advantage of 1. Because you're just pulling straight down, it's lifting the object up. So rather than just picking that item straight up, having a pulley, the force pulling down, you're going with gravity. And so it's going to be easier to lift that thing with the help of a pulley because you're going with the same direction as gravity, and it gives you leverage to be able to lift that weight with the pressure also going on the pulley, not just on yourself. So that's a fixed pulley. A movable pulley is a pulley that connects to the object being moved. The pulley sits at the lowest point of the rope with the object attached to its axle. Half of the object is supported by the rope attached above it, and the other half is supported by the other end of the rope, the place where the effort for it is exerted. The mechanical advantage of a movable pulley is 2, because the effort force is only half of the resistance force. So in this case, you have your rope or cable attached to the ceiling, so that doesn't move. Your pulley is down here, and your force is attached to the axle of it. So here's our load. And on this one, you're lifting up your force. And this one has a mechanical advantage of 2 because it's using the rope here and the rope here in order to lift that object. So it has a mechanical advantage of 2. Okay. Combinations of pulleys can be strung together to further reduce the force to move an object. By combining pulleys, heavier objects can be hauled or lifted. An arrangement of pulleys designed to move heavy objects is called a block and tackle. To figure the mechanical advantage of a complex block and tackle arrangement, count the number of ropes that bear the load. In a single movable pulley, The mechanical advantage equals 2 because 2 ropes share the load. In a block and tackle, and where there are 3 ropes to share the load, the mechanical advantage is 3. The load supporting ropes pull up. The rope that is being pulled down does not count. It's sharing the load of the adjacent rope. So when you have a block and tackle, you have it's a movable pulley you have attached to the wall here, and your load would be down here attached to the axle of your pulley. But then you also have a fixed pulley up here attached to the ceiling, and then you are pulling down your force to pull that item. And so you have 1, 2, 3 ropes that are being used to lift that item, and so your mechanical advantage is 3. Your weight is being distributed over more pulleys, which lessens the amount of force you yourself have to use in order to lift that heavy object. All right, and in all of these, we are lifting our load up. Okay, a machine that needs less force requires more distance. How does this fact affect pulleys? In a pulley system with a mechanical advantage of 2, like our movable pulley, the rope must be pulled twice as far in a system with a mechanical advantage as 1. So in this one, in our movable pulley, you have to pull that rope twice as far as you would in your fixed pulley, which has a mechanical advantage as 1. Okay, so this one, let's say you had to pull this 2 feet in order to lift it. You would have to pull it 4 feet here in order for it to go the same distance up. Okay? In a pulley system with a mechanical advantage of 3, the rope must be pulled 3 times as far. So if your mechanical advantage is 1, in a block and tackle over here where it's combined, you would need to pull it 6 feet in order to get it to go the same distance. So your rope needs to be longer. The more blocks you add in your block and tackle, the longer your rope needs to be, but the easier it's going to be to pull that item up. Of course, friction has an effect on real-life situations, which results in the need for more force to move an object. Friction reduces the mechanical advantage. So the more blocks and tackles, the more pulleys, or like over here in our combined pulley, the more pulleys you add, the more surface area you're adding. And remember, friction is 2 objects rubbing together, which causes a slowdown. And so the more pulleys that you add to your system, it is going to be easier to pull it up, but it's going to have a higher friction level than, say, a fixed pulley with 1 pulley system in it. So the more you add, the higher the friction level is going to be, which does slow down the mechanical advantage a little bit. Some examples of pulleys on the side of your page. You have a ski lift pulley, an elevator motor and pulley, glass elevator and pulley, and a window washing pulley. That is a job you will never see me ever do. I will never be a window washer. I can't believe people can go that high on the outside of a building and be okay with it. But thankful to pulleys, they are able to do so safely and efficiently. Something else, if you do like heights and if you like rock climbing and dancing, there's a career for you down in the purple box, vertical dancers. Maybe you've considered mountain climbing as a hobby or dancing as a career. Do you know there are people who do both? Vertical dancers gracefully and fearlessly leap and swoop alongside skyscrapers, mountains, and cliffs. Every move requires the combined skill of dancing and rock climbing, with a constant attention to risk management. The choreography is beautiful and breathtaking, a delightful combination of fine art and architecture. How did the dancers manage to move vertically while defying the laws of physics? They are secured with harnesses, carabiners, and climbing rope. Simply put, they are attached to movable pulley systems, which allow them to move up and down along a variety of vertical and irregular surfaces. The choreography and challenges change for each new venue, often pushing the dancers to their limits. Hours and hours of practice and preparation result in a unique and spectacular work of art. So that might be something that if you have some time, you can look up on YouTube, vertical dancers, and see how they use pulleys in order to exhibit their art on the side of buildings or mountains. Interesting. So lesson in review. Here's some questions that we're going to answer today. Number 1, what is a pulley? So define it. What is a pulley? And which pulley gives a greater mechanical advantage, a fixed or a movable? So go back to our pictures. Our mechanical advantage was our first ones circled. So the more, for each rope that you have, your mechanical advantage increases by 1. So which is going to have a higher mechanical advantage, fixed or movable? Number 2, how does adding more pulleys to a system affect the mechanical advantage and why? Is your advantage going to go up the more pulleys you add? Or is your mechanical advantage going to go down? Remember, your mechanical advantage correlates with the number of ropes you're using. So if you're using more ropes, is your mechanical advantage going up or down? Number 3, what is the mechanical advantage of a block and tackle system that contains 4 pulleys? Again, remember that your mechanical advantage correlates with the number of ropes you have or the number of pulleys you have. So if you have a 4-pulley system, meaning you're using 4 ropes, what would the mechanical advantage be? Number 4, if you add more pulleys to gain more mechanical advantage, what else do you have to add? Okay, so remember, the longer or the more pulleys that you have, you also have to add something else. And that was our second number here. Okay, our second numbers told us how long your rope needs to be. So the more pulleys you add, the longer what needs to be in order for that to work. And number 5, what happens to the frictional force when more pulleys are added? Why? And how does that affect the mechanical advantage? So the more pulleys you add, is your friction level getting higher or lower? And remember, friction levels correlate with the amount of surface area that is being used. Okay, and how does that affect the mechanical advantage? Is that going to make the mechanical advantage higher? It's going to make it easier? Or does it lessen the mechanical advantage a bit by having more surface area, which does create more friction? So go ahead and answer those questions on line paper. And you do not have a lab today. Next time, we're going to go on to the next kinds of simple machines, which are screws and wedges, wheels, and axles. So we're going to look at some other ways that we use simple machines in our everyday life. Until then, look around your house. If you're out in a car, look around as you're driving by things. See if you can find pulleys in the world around you, whether they're fixed pulleys or movable pulleys or a combination of pulleys, and think about how they're used and how they make that job easier. I'll see you next time.